things cannot cross through nonpolar regions. Well, that means then that we need some way to get those polar things, things that have a hard time crossing the lipid layer, we need something to help them cross through the barrier. So we have proteins that are embedded in the cell's membrane. Some proteins go all the way through. Some are just like a flag stuck on the surface. They don't go all the way through. And some are just stuck on the underside. You can't even see them from the outside of the cell. Because these proteins have a lot of different jobs. Some of the jobs these proteins will have are, one, to help maintain my cytoskeleton, to keep it in place so it doesn't move around. They can be binding sites for chemicals like neurotransmitters and hormones. So I would write that down, neurotransmitters and hormones. They can also be a passageway for ions to move through, or they can work again for neurotransmitters and hormones for communication. And they can also be a tunnel. And we're going to kind of look at these a little more in detail this morning a little bit. Things go from outside of the cell membrane, try and go through a cell membrane to get inside. Or why stuff inside of a cell want to leave in the first place and try and go outside. Most things are under the law of chemistry or physics. A principle or process called diffusion. You need to memorize this and truly have a good, strong grasp of it. It is the spontaneous movement of a substance from region of higher concentration to region of lower concentration without the need of energy. That maybe should be your last thought as you're dying of a nice old age. All right? But also take it apart. When you look at definitions of words, take the time to go, do I truly know what this is meaning? So do you know what they mean by spontaneous? Yeah, it means something has to trigger it. It just happens by itself. Okay. Without the need of energy. And we're calling that energy for right now ATP. All right, so this stuff can go from regions of higher to regions of lower. And that gives us what's called a concentration gradient. Right? Look at the word concentration. It doesn't mean thinking and thought in this sense. It means the amount of stuff. So a concentration gradient is the difference in the amount of stuff between two places. So let's compare in this room the concentration gradient between professors and students. Which is there more of?
Students.
Students, right? So there's a huge concentration gradient, right? Way more of you than there is of me.
Mm.
When you look at, well, we'll hold that thought for a second. Now, it's because of the concentration gradient that diffusion happens. If there's no difference, if there is no gradient, you have an equilibrium, right? Equal, meaning the same. You have the same amount between two places. And if there is the same amount between two places, there's no net diffusion. And here's where we got to begin getting down this idea. You guys will have net diffusion. And just